Okay, so now I have my velocity final, which is also equal to my velocity initial in the kinematics equation.
Mm-hmm.
So, now thinking about my kinematics equation, I have V final squared plus V initial squared is 2A delta X. And she says, how far horizontally will she touch down? So we're looking for delta X. But we also have to solve for something else.
You have that written down, right? What the velocity would be?
Yes.
Okay. So basically, she comes off the end of this ramp, right?
Right.
With a velocity that's equal to the square root of 2 GH in final minus GH initial.
Mm-hmm.
And she kind of goes out like this, she lands. And you want to find this distance. Here to here.
Mm-hmm.
So if it's just a kinematics problem,
Mm-hmm.
what would you do once you have your picture drawn?
I write in all my equations and my knowns.
Yep.
So I know that so now my height, because this is height 1 minus height 2. It does that still is keeping with the 25, right?
Right, yeah, but this is the end as she leaves the ramp. How high will she be when she goes off the ramp?
3.
Yeah.
But for my velocity, I still include the 25 meters.
Right. So if you wanted to put this in, you could solve this right now. You can do it symbolically the rest of the way. Either way it works.
Okay.
I'd probably solve it right now because you'll be using real numbers the rest of the way too.
Okay.
You can, well, it doesn't matter. Whatever your teacher wants you to do. But this is just going to be, you just have to keep track of that the whole time.
Right. I'll probably solve that. Or I'll just say that's velocity initial and then plug it in later.
Yeah,
Because
that works.
Okay, so now where do I go? Because I know now I would say we know our velocity initial. We know our y final is equal to 0. Our y initial is equal to 3. We know our acceleration is constant. And in the x direction is 9.8.
In which direction is it 9.8?
The x, y?
Yeah, in the y direction. Because that's your up and down.
And in the x direction it's 0.
Okay. All right. So what's your x initial?
0.
Yeah. So you just make it 0 so that your equation's easy.
Okay.
Your x final is what you're looking for. It
Mhm.
looks like a 0. So it's actually
Uh-huh.
2. Okay.
Okay.
And then your time here is 0. But what kind of velocity is that?
What do you mean?
So we've got an x initial position and a y initial position. So we can put those into kinematic equations. But our kinematic equations we have to use in just one dimension, right? So is this an x or a y velocity?
Oh, good question. What if it's the y?
If it was the y, it would only be in y, right? That's kind of a trick question because it's both. Because this is Vx, this is Vy. So she comes off the ramp at an angle, which means her initial velocity has an x component and a y component.
Oh, wow.
So how do you know what angle she came off of it at?
Because in the book it says that this angle is 60 degrees. This one is 90 right here. So this is 60, this is 90. So what up, so it'd be 45? Would it be a 45 degree angle?
Let's look at it. So the curve kind of throws you off, but if you get rid of the curve, you make this a 90 degree. So this is a 90 degree angle.
Mhm.
So if you make the curve into another 90 degree angle, this is really bad. So you got 60 degrees, 90 degree angle. This one's 60, right? This one's 90. So what's this one?
That would be 30.
30, yeah. So this angle right here is 30 degrees.
That's what I was first thinking. Okay. Wait, don't erase that.
Oh, sorry.
So here.
And even if you have the curve in there, it still works, but it just looks a little strange.
So that would mean that our velocity in the x is equal to a velocity initial times sine of theta.
So this is your 30 degree angle. So which one do you want to use, sine or cosine?
This is our 30 degree. Oh, that's our 30 degree. For our, let's see,
Yeah.
for y.
Oh, did you say y or x?
I said both. So opposite over hypotenuse would be our y, which would be our sine.
Oh, okay.
So Vy is equal to velocity initial sine of 30 degrees. And Vx is Vi cosine of 30 degrees.
Yep.
Okay, didn't think about that. So now we can plug into the kinematic equations. I would think to use velocity final squared plus velocity initial squared plus 2a delta x. Would that work? Because then we don't have to solve for time.
What's your acceleration in x though?
0.
Yeah.
Oh.
So this whole term would go to 0 and you'd never be able to find out what delta x really was.
Okay, so we could do the equation x initial is equal to x final plus 1/2 a t squared. Is that it?
So it's x final
Okay,
equals x initial,
okay.
and then there's the part that came from velocity, right?
Mhm.
So velocity initial times time plus 1/2 a t squared.
So we have to take another equation and solve for time. Okay, so, and we also know that we have velocity final is equal to velocity initial plus
At.
AT, right? So T is equal to velocity final minus velocity initial divided by A.
Right, but which direction are you going to try to do that in?
Well, we were thinking about it in the X, but that doesn't work.
Right, because your acceleration cancels out time again. And you don't know the final velocity for either one, do you?
No. So what would you suggest?
So if you go into the y, so in these kind of kinematics problems where you have two dimensions and you don't know time, usually you know enough about the y direction to find time using y.
Okay.
And time is going to be the same for both of these, right?
Right. So we do velocity final in the y, velocity initial in the y, ay, and ty.
Yeah, but you don't know velocity final on y again. So you can find it directly if you use y final equals y initial plus the initial y t plus 1/2 a t squared.
Okay.
Because then you know your y final is 0, your y initial is 3, then you have your velocity in y initial is v initial sine of 30 times t plus 1/2 negative 9.8 t squared. The only downside is then you have to use the quadratic formula to solve for t. That's the only way to do it.
Okay. And then we'll find t. We'll plug t into this, to the x equation.
Mm-hmm.
And then we would plug in everything else that we know. For the x equation, it says velocity initial in the x, which is what we solved for. And then we would be able to get the velocity final.
Yep.
I mean the x final.
And when you put it into the x equation,
Right.
that's 0 and that's 0, so it's actually just your velocity times that time. So after that, it's pretty simple.
Okay, cool. Well then I will do that one my own time then.
Okay.
So that one was